We can all do that. We've done that thousands of times in our lives. Okay? Suggestion at this point,
By computation.
combine like terms, right? That's usually what we do. Okay, so let's just take a trip back to polynomials 1. We are going to combine like terms. And correct me if I'm wrong, guys, but by like terms, what do we get? I think I forgot an x, didn't I? Oh, no, I didn't. We get x squared minus 4x plus 4, correct?
Yes.
Okay.
Can you write like by computations instead of like terms if you don't remember right?
Yeah, it's fine.
That's
I mean, that doesn't hurt my feelings. By addition, if you
But-
want to, because that's technically what it is.
Okay.
Okay? After you've probably seen it a few times, you'll be like, oh yeah, it's like terms. Okay? What do we need to show? We need to show this is a perfect square,
Square.
right? Suggestion?
X plus 2 whole square, right?
Okay, we can factor this, right? So by factorization, and Art, I'm just going to change one thing in there. Doesn't this become x minus 2
Minus, yep.
times x minus 2? Okay, that's just factoring your trinomial. Okay. If you don't trust me, FOIL it out. Okay, I promise it's going to be x minus 2, x minus 2. Which is the same thing as what, guys?
X minus 2 whole
X
square.
minus 2 quantity square. If you want to skip this step and just go right to x minus 2 square because you see the pattern of the trinomial, that's fine with me. If you don't see it, this is what I always teach my lower level algebra students to do. Okay? So once again, by factoring, because that's what we're really doing, this becomes x minus 2 quantity squared. What do we know about x minus 2, guys? It's an integer, right? Let's call it k if you want to. So by closure, this becomes k squared, and of course, k is an integer. So this is probably one of the ones that looks really intimidating, but quite honestly, guys, it's an Algebra 2 problem at most. Okay, that's what we're going to be finding out throughout this class, that most of the operations that we're doing algebraically, no trigonometry, no differential or integral calculus, just straight up Algebra 1 and 2 stuff. Okay? Yeah, that's a good or bad thing, depending on how good or bad you are with algebra. All right. So, isn't it true that by above, can we say that this nasty thing that we started with is equal to k squared? Okay, so by above 5 quantity x squared plus 1 minus 4 quantity x squared plus x minus 1 is equal to k squared. And is that good or bad?
Excellent.
That's very excellent, which because what does that mean, guys?
Perfect square.
It's a perfect square by the very definition of perfect squares, right guys? So we could say, which is a perfect square by definition of perfect square.
Would you not have to include for all x existence in the integer?
No, we already did that up here. So we already know that x is an integer by previous definition. Think of that as almost like a global variable, if you would. We've defined it all the way back up top. So, and you guys know global variables are dangerous sometimes, but in this case it's just math, so who cares, right?
Right.
So, which is a perfect square. By definition of perfect square. I'll get out of your way in a second. Okay. Okay. So, questions about any of these proofs that we've done so far? And of course, I'm going to let you guys practice one of these. Okay?
Why do we not have to define it on top again?
Oh, you mean the x or?
Yes.
So once this x is defined, it's already an integer all the way through. Okay. And then we don't have to define. Now, are you asking why we don't have to define x again down here?
Well, for the last one we did, we said by definition of even, so.
Right. So, but remember, x is just an integer. It's not even nor odd. So we don't have to reuse the definition of even nor odd because we never utilized it.
Alright.
The only definition that we utilized was perfect square, and that was at the end of the problem. Okay, does that make sense, Adam?
Yeah.
Okay, other questions, guys? Okay, let me start you out with this one, okay, because I want to make sure that you guys get a good shot at being able to prove this, okay? So, if A and B, or, I'm sorry, for all integers A and B, oh, John, you need me to go back up?
Yes.
Okay, that's all right. Is that good enough, sir?
Yes.
Okay. All right, I'll start down here. Okay. For any integers A and B, if A and B are perfect squares, then this ugly structure right here is a perfect square. Okay? Now, it is true. If you don't trust me, pick two perfect squares, throw it in there, you'll see it works. Okay? So, let's start this out. Okay? How many variables do we need?
2.
2. Okay, so let's let A and B be elements of the integers. Okay. A and B, arbitrary or particular. That's funny, A and B, and then it looks like A and B right here. That's not really that funny, sorry. Arbitrary or particular. But there's one other thing that we have to say about A and B in this problem. We have to say that they're both perfect squares, right? Because isn't this a conditional statement? We're saying that if A and B are perfect squares, which means we have to make that assumption, okay? Because this only works for perfect squares. The previous problem worked for any integer x. This one only works for perfect squares. So we're going to say, let's let A and B be integers, where A and B are perfect squares.
You have to write that A and B are equal to like A squared.
Right, we're going to use the definition of perfect squares. Very nice, gentlemen. Okay? So, since we know that they're perfect squares, we have to use the definition of perfect square. Okay? So, what's the oh, go ahead, Brian.
So do we still have to write that A and B are perfect squares in a sentence, or can we just write it?
Yes, we still have to do that, because we can't just jump right to the definition of that without defining that. Okay? So we first define it, then we use the definition. Okay? So, by definition of perfect square, so what can we say A is equal to by definition
Square
of
root
perfect
of
square?
A.
What's that?
Square root of A.
Square root of A. N square, K square, whatever you want to do, okay? So let's say A is equal to N square, okay? Where N is an integer, right guys? And B is equal to another integer squared. Let's say M squared, K squared, doesn't matter, as long as it's different. Okay, so that's how we're going to start this out, provided that my in the element is an element, looks like a little bit of an element. Let's try this again. There we go. Okay. Now, what I'd like for you guys to do is to try to finish this off. Okay? So, do your substitution, do your algebra, and see if this works out for the rest of us. Okay? So let me give you guys a good 5-6 minutes. Okay? You guys can work together if you want. If you don't like the person next to you, then, oh well, sorry. Move around. And if you move around to anybody and you still don't like somebody, it's probably you. It's not them. You're just a jerk. And of course, if you need help, raise your hand. Okay, certainly want to help you guys out if I can.
So if we do this, we have this a
Yeah.
squared plus twice ab plus b squared, but since there is no twice.
Oh, no,
so-
there is a 2. There should be. Oh. Yeah, there should be a 2 in there. Okay. I have to write a 2 in there to make this true.
Okay.
Otherwise, it's not true. Sorry, guys. Let me change the problem just so it works. You can't do that on a quiz or exam, sorry. But there should be a 2 right here. I just made a copy here when I typed it. Sorry. Sorry, my bizzle, my bizzles. Apologies. Just write on the teacher evaluation. It's fine.
Make multiple mistakes.
How do you know somebody else didn't type this stuff?
You said that right now.
I mean, that's
You
what
said I.
Oh, no, I made a mistake. That's fine. I'm just asking him how he knows.
Maybe your mistake was in saying
It might have been. Maybe my mistake was turning down that job at APG for 3 times as much as I made here.
maybe.
Maybe.
Now, should we use like factorization or GCF? Because there are two variables over here.
Neither.
Neither.
Just regular factor. Oh, I'm sorry, just factor.
by factor.
Okay, yeah, it's not GCF. Sorry to torture anyone. And by the way, if you can't justify all the steps, that's okay. Okay, we're still learning how to justify the steps. So, but the algebra you guys should be fairly competent with. Oh, right, I'm sorry. Go ahead.
So
Sir.
why do you have a two as the right?
Well, what happened was, okay, I decided that to make the problem work, I put a 2 up there.
Oh,
Otherwise, it wouldn't work without it.
Gotcha.
Yeah. Now, and I did tell the class that you're not allowed to do that on the examination. Just like change the problem to make it work. So, sorry about that. Being a teacher, I do get some sort of privileges, and that's one of my privileges, that I can change the problem to make it work. Take a couple more minutes, guys. I think there's only about maybe 2 or 3 algebra steps, so. Art, did you want me to come back and look?
Yeah, I think I'm done.
I'm a bit of a math pervert, I like to watch. Oh, that's sexy, I like that.
Yeah.
Yeah, that's hot.
All right,
You
thank
know
you.
what I like.
Thank you.
Things that you should not say to another man. Take one more minute, guys, we'll go through this answer together. And then we shall move on. So, I'm hoping that when you guys started, you performed the substitution, okay, and you plugged into this revised statement up here. Okay, so instead of having a plus 2ab plus b squared under the root ab, n squared plus 2 roots of n squared plus n squared. Can somebody tell me algebraically what they did next to be able to simplify this, or what they thought they could do with this?
n squared plus 2nm plus m squared.
So we have the product of two perfect squares under a radical, right guys? Well, if you're squaring and taking a square root, aren't they inverse operations? Now that's true for multiplication, but not for addition and subtraction, okay? So if you guys go into your, if you guys go into your Calc 2 class and you do this, square root of x squared plus 1 equals x plus 1, okay? You just violated the trigonometric substitution rule and your teacher might punch you in the face. All right, hopefully they don't. I don't know.
Is that secant or tan?
What's that?
X squared
That's
plus
tangent.
tangent.
Yeah, that would be 1 tangent of theta. Okay, so we're going to say n squared plus 2nm plus m squared, okay? That's just going through and using a square root on those, okay? You could just say exponent rules or radical rules. It technically is a radical rule, okay? So radical or root rule, okay, that works. Okay. So what's the next thing you guys might have done at this point now that you have at least no more radicals in this problem?
Factoring.
You can factor it, right guys? Isn't that like the form of a perfect square binomial? Okay? So this would factor, if I was to factor that guys, what two binomials would that factor into?
n plus m times n plus m.
Yep, n times n plus n times n
N
plus n times n. Sorry, I just couldn't alliterate it nicely. Okay, so this is n plus m times n plus m. Okay? Otherwise known as n plus m squared, right guys?